Alright, so I am going to do the second part of the test review. This is where you get into the calculator part of the exam. And to begin with, we're going to look a little bit law of sines problems. So typically, what we're going to look at is some triangle problems, law of sines, law of cosines, area of triangle, and a little bit of polar coordinates in this section here. So to begin with this section, one of the things that you want to do is see what situation you have. So the first thing that I notice on this is I have a side, then I have a angle, then a side. So anytime I've got the side angle side case, you want to start with the law of cosines. And the law of cosines takes on three forms. I do give you these formulas, but as I was saying in class, it's a little better off if you just get these things down so that you can work with them real fast and speed up the process of your work. So there's three forms like this. They always start with the square of a side. And it's easy to remember. What you do is if you have a squared, you say the sum of the squares of the other two sides minus twice the product of those other two sides times the cosine of the angle that's opposite that a, which would be capital A. Next one goes the same way. B squared is the sum of the squares of the other two sides twice the product of those two sides, and this time it would be cosine of b that matches with little b. And then the last one would be other two sides would be a squared plus b squared minus 2ab, and then the cosine of the angle opposite c is c. All right, so this one, what you want to do is you want to start with finding this. So we're going to start by just writing out the law of cosines, right? And what we're going to do with this is we're going to use this second form right here. Again, I don't even look at it, and you shouldn't either. Just do this. It's the sum of the squares of the other two sides. So it's going to be 5 squared plus 10 squared minus twice the product of those two sides, 5 and 10, times the cosine of the angle that's opposite b is going to be 40 degrees. And this is a problem that what I want to see is basically this. I need to see that you have set it up in the law of cosines correctly, and then from there, you're basically just going to go to your calculator. So be sure that you're in radian mode as you're working with triangles, and we'll do this in one step. Whatever you can do in your head, you're more than welcome to do that. So we got 5 squared plus 10 squared minus 2 times 5 times 10 times the cosine of 40. And you can get that answer. So I'm going to write that down and putting all the decimals in there. So 395555569. And then what you would do is you would do the square root of both sides. And then we can round that to one decimal place, whatever is specified in the problem. So what I do is that this is stored in the ANS key, which is a memory key. So one thing you can do is go second, square root, use that ANS key. That'll automatically plug the 48.39 in using all the decimals. So we get an answer. If we round that, we got 6.956 and some other decimals. If we're going to round that up because of the 5, then we're just going to round that to 7.0. So the answer is going to be 7.0 units, whatever that is. Now, all we're doing is finding one side of the triangle. Now, sometimes I do that, too, on tests, is instead of solving the whole triangle, I might ask you to find one part of it just to save time on that. Okay, now the next thing we're going to look at is problem number 2. We want to, first of all, see what situation we have. This problem, you're just asked to find the value of angle A in the problem. So this time, what you're given is you're given all three sides, and anytime you're given all three sides with the side case, again, this is going to be law of cosines. Okay, so since I'm finding angle A, I want to use the law of cosines that relates the side opposite A. So I'm going to write down A squared equals the sum of the squares of the other two sides, and then times the cosine of the angle that's opposite A. So we're going to do that. Now, if I'm going to find the cosine of A, the way I like to do the problem is just solve this equation for cosine A. So I'm going to just rearrange this formula. So I'll have A squared. I'm going to move the B squared to this side, subtracting from both sides. I'm going to subtract c squared from both sides. And that's equal to negative 2bc cosine of alpha. Then I'm going to divide both sides by negative 2bc. Then I'll be prepared to solve that equation then. All right, so I'm going to write down what I have. I have a squared minus b squared minus c squared all over negative 2bc is equal to the cosine of alpha. And then I can go ahead and just get everything plugged in and go to my calculator. So starting with this problem, be careful about everything now. So a is going to be 8. So I'm going to write that down. B is going to be the side opposite B, so B is equal to 6. And then C is going to be opposite C, so C is going to be 4. So now I can plug everything in then. So I've got A is 8. I've got B is 6. C is 4. And then we're going to divide by negative 2 times B times C. And then I'm going to crunch that out on the calculator, and then I'll end up having to, of course, take an inverse cosine of both sides then. So I'm going to go ahead and do that now. So if you want to do this in one step, the way to do this is to put the numerator in parentheses. You just go 8 squared, subtract 6 squared, subtract 4 squared, close parentheses, divide by, and then you want to use a new set of parentheses to do negative 2 times 6 times 4. And you can do things in your head if you want to speed up the work a little bit on that. So you end up getting that value right there then. Okay, now let me double check the calculations on that, because I think I've done something incorrect here. So let me pause here. Okay, well, I think I'm okay. So, and I was thinking about that negative. You've got an obtuse angle probably on here, so the cosine of inverse cosine of a negative is going to put you in quadrant 2 anyway. All right, so I'm going to write that down, and then what I'm going to do is the inverse cosine. All right, like that. So I'm going to go ahead and do inverse cosine of negative 0.25, and see, that'll give me an obtuse angle, so which is okay. So we'd end up getting for the answer, A is approximately, round this to 1 decimal, about 104.5 degrees. All right, so that's okay on that. Since you have an obtuse angle, that's why it's acceptable to have a negative value you've taken an inverse cosine of. So we round that to 1 decimal, and then that finishes off that problem. Okay, so what I've done so far is I've done 2 examples of law of cosine problems, not solving the whole triangle, but just finding that one part of the problem. So I don't have you solve triangles over and over again on the problem, sometimes just finding one part. Okay, now we go to the next thing. The other thing is I don't have to give you a triangle diagram. Typically, I like to kind of test students and make sure that they know the naming convention on triangles. So I'm going to go ahead and let's draw out a triangle, and I've got a real long side B, so I'm going to kind of write that like that as my 32. Okay, then I've got a short side A, and then I've got a bigger side C, so I'm going to kind of try to draw this to scale, although it doesn't really make that much difference on these problems, really. Okay, so I'm going to call that my side C, being 26, and then I'll call this my last side. That'll be my side A, which will be 14. Okay, so if I label this, then this is going to be C. The side opposite A is going to be A, and then the side opposite B, the angle opposite B, is going to be capital B. So I've got everything named the way I need to. Now what you're doing on this one is you're doing an area of a triangle. You don't have to draw a diagram on this. So if you're finding the area of a triangle, notice that what you have is the side case. So that means that you're going to use Heron's formula to work this out. Okay, so what we'll do with this is let's start by writing down Heron's formula and then getting that all put together. All right, so Heron's formula takes on 2 parts. It's generally got this semi-perimeter where we add the sides and divide by 2. The second part of the formula is the area is the square root of this semi-perimeter S, and then S minus A, S minus B, S minus C under the radical like that. So we're going to start by adding the sides. 14 plus 32 plus 26, and we're going to divide that by 2. You'll be able to utilize your calculator on this problem. So if I do this, I've got 14 plus 32 plus 26, so that's going to give 72. And then if I take 72 divided by 2, that's going to give 36. Okay, so now what I'm ready to do is I'm ready to plug everything in to the formula, and then I can do the calculation on this then. Okay, so I'm going to go area equals, then under the square root, we're going to have the semi-perimeter 36, and then 36 minus A, which is 14, then 36 minus B, which is 32, and then 36 minus 26 to get that, and then we can go directly to the calculator to finish that up. And you can do this all in one step on the calculator if you want to. You don't have to do anything on this other than just work with the calculator. All right, so I'm going to put in square root, and I'm going to put 36 and just type it in exactly like it is. Let the calculator do all the work. So 36 minus 14, 36 minus 32, and then 36 minus 26, and double close those parentheses like that, and that'll give the area, which is about 177.988. We're going to round this probably to, let's say it says 2 decimal places this time. Okay, so if I do 2 decimal places, we'll need to round that up to 177.99 as our approximate area on that problem. Okay, and then you want to put that the units are squared. So you've got squared units. So your answer is 177.99 squared units. Okay, so that's Huron's formula. Real simple to remember how to do that. That's how you find the area of a triangle if you have a side-side-side case. All right, next thing is going to be, we're finding the area of this triangle. And this time you're given a totally different case on this. So you're given a side angle side case. So the way to do this is, we basically learned these formulas like this. There's 3 forms of these things which are given. It's better if you learn in words how to handle this side angle side case, but the formulas basically go like this. There's different versions of this. So one form is going to be, if you take this angle that you're given, now see, notice this is angle B here. So one of the forms that you're given is you're given 1/2 times A times C times the sine of B. Okay, then you're given other forms of this. Okay, like the other one is going to be, like if you know side A, then the side angle side case, you would have a B and you would have a C, and then you'd have sine A. So see, you always have the other 2 sides. It's actually pretty easy to remember. You have the other 2 sides. And then the other thing on this is you would have like sine of C. So if you have C, the other 2 sides opposite 9 are just going to be A and B. So you have that formula like that. Now you don't have to memorize those necessarily. The best way to do this problem, in my opinion, is just when you have a side angle side case, talk it out in words. What it is it's 1/2 the product of the 2 sides that you're given times the sine of the angle in between. So you're basically just using this formula right here and plugging that in. And then you can go directly to your calculator. All you need to do right on your paper is just is this right here. And then you can go like this. You would go 0.5, 1/2 times 2 times 9. And then times the sine of 25, making sure that you're in degree mode. And then that would give you the area of that triangle. Okay, so the area of that triangle is approximately 3.80 squared units if you round that to 2 decimals in. Okay, so that's the other things you want to handle is the side case of finding an area of a triangle, and also the side angle side case like that. So it's very simple, 1/2 product of the two sides times the sine of the angle that's in between those two sides. That's it. Okay, now let's move on to a couple of application problems. So the other thing I like to do with triangles is applications. Make sure you can set up a diagram. Use either law of sines or law of cosines to interpret the problem. So let's read the problem. Let's see if we can get this built. So it says you have a balloon 939 feet high. The angle of depression to a headquarters from the balloon is 80 degrees 50 minutes. How far is the headquarters from a point on the ground directly from the balloon to the nearest foot? Okay, now this one, let's go ahead and just sketch out a diagram of this. So I'm going to start by just saying, okay, here's my balloon. And the balloon is at a altitude of 939 feet. So here is my balloon. That's pretty good artwork there. Nice job, Brad. Okay, then it says from a balloon that high, the angle of depression to a ranger headquarters. So you got this headquarters down here. And then you're looking at an angle of elevation to that. So let's draw a picture of that. So just kind of trying to get our angle put together here. So one of the things you're going to have is you're going to have a line of sight that's parallel to the ground. And then what you're going to be doing is looking down at the ranger headquarters from the balloon. And then that's going to give an angle of depression like this. And I didn't draw this to scale. Doesn't really make that much difference. So it says this angle of elevation here is going to be 80 degrees 50 minutes like that. Clearly not drawn to scale, but all you're trying to do is get the idea on this anyway. Okay, so we got this. We got those two parts like that. And now what it says is how far is the headquarters, this part, from a point on the ground directly below the balloon. So what you'd probably want to do on this particular problem is go ahead and just assume that that's at a right angle like that. So we're just going to make that assumption that we have a right triangle, and then we can do right triangle trigonometry on this then. Okay, so the idea is we're trying to find this side of the right triangle like this. These are parallel lines. This line of sight and this are parallel, so that means these things are alternate interior angles, so this angle is the same as this angle. Okay, now if you talk out what you have, looking at these three things, in relation to this angle you have opposite over hypotenuse, so that means we're going to use the tangent. So we know the tangent of 80 degrees 50 minutes, that's the opposite over the hypotenuse, so that's going to be, did I just say hypotenuse? I don't know what I'm talking about here. How about adjacent? Pay attention here. Okay, opposite, adjacent. So what we have is 939 feet all over x, and then we can solve this equation. So you could cross multiply this if you wanted to, so you would have x times tangent of 80 degrees 50 minutes is equal to 939 feet, and then we can divide both sides by the tangent of 80 degrees 50 minutes, and then we can go to our calculator to get the problem put together then. Okay, so that'll cancel out, divide out. Now we go to the calculator, and when I go to the calculator on this, what I want to do is just punch those things in. You want to be sure that you're in degree mode when you do this then. So let me move the calculator over here, and then we can crunch it out. Okay, so I'm going to put in 939 divided by the tangent of, and you can do this one of two ways. You can go 80 and then you can go second apse to get that angle to come out. So you get 80 degrees, then you can go 50 minutes. You can do the same thing, second angle, and get this to come out. You can do it that way if you want to. And then we can round that off. So that answer is going to be about approximately 151. You're supposed to round this off to the nearest foot. So that's going to round that up to about 152 feet as the answer to that problem then. Okay, the other thing I wanted to show you on this is, so that's the rounded answer to the problem. You can also put this in your calculator like this. This is the way I always do this. I just go 939 divided by tangent, and then I just put 80 plus 50 parts out of 60, and then that way that converts it to a decimal degree automatically, so it's going to give the same thing. So you can do that either way. Okay, that's a right triangle trigonometry problem. So now at the bottom of the page, the next thing we want to look at is this one. So this problem is saying that you have a guy wire to the top of a tower, makes an angle of 51 degrees with level ground. At a point 31 feet further from the base of the tower and in line with the base of the wire, the angle of elevation to the top of the tower is 30. What is the length of the guy wire? So again, let's go ahead and let's get a diagram built on this. So we have a tower, and let's go ahead and just try to get a triangle diagram on here. So let's say this is our tower. Okay, and then you have a guy wire. So this is going to be like your guy wire. And what it's saying is that is making a angle of 51 degrees with level ground. Okay, so that's what I'm assuming that's going to be. Then what we're going to do is we're going to go 31 feet further back. So we're going to go backwards a little bit. That distance right there is going to be 31 feet further back. Then we're going to remeasure the angle of elevation to the top of the tower. And of course that's going to become a smaller angle. So that's going to end up being 30 degrees like that. So that's your diagram. Now, we don't really have to make the assumption that that's a right angle, because we have enough information to solve that anyway. So what we're going to do is we're going to find this length of the wire right here. So we're doing that. So if you look at this problem, we have an oblique triangle, and I'm just going to go through and highlight this oblique triangle that we got there, and we're going to see if we can figure out enough information to do that then. So ultimately on this problem, if we're going to use law of sines, we can match x over 30, the sine of 30, but we also got to know this angle right here, and in order to find that angle, we got to find this angle. So what we're going to do is a couple of simple calculations. This angle right here is just going to be 180 minus 51 degrees. So we can calculate that out, and then that'll give us this obtuse angle, which is 129 degrees. Then we've got these three angles here, so we can just subtract from 180 to figure out what that angle is. So we're going to get 180. We're going to subtract 30 plus 29, and then we'll get that value. So we can just go like this on the calculator: 180 minus the 30 degrees you were given, plus the 129 that we just determined, would give you a leftover angle of this, which is going to be 21 degrees. Okay, so now we've got everything we need. So what you really have on this problem is you have the following oblique triangle. So you've got a side here, like that, and then you've got a side kind of going like this. So you've got this side here, and then you've got another piece that's kind of going like this. So that's enough information now to use the law of sines. So in this problem we have these things. We have 21 here, we have 129 here, we have 30 here, 31 there, and then we have x. So if we're going to match this up using law of sines, we do that side matches with that angle, this side matches with that angle. So we're ready to do the law of sines relationship. So we just do x over sine 30 equals 31 over sine of 21 degrees, and then we can solve this equation. So I'm going to multiply both sides by sine of 30. Okay, and then we can go directly to the calculator. So we're going to crunch out x equals 31 times the sine of 30 degrees, and then we're going to divide that by the sine of 21 degrees. Then we should have our answer to our problem. Okay, so let's put that in degree mode. So 31 sine 30, close parentheses, divide by sine of 21, and that will give approximately 43.25. We're supposed to round this to 1 decimal. So let's round that up to 43.3 feet would be the length of the wire then. Okay, so that's a law of sines problem. Okay, now we're going to do a graph of a polar equation on the next page. So let's run through this. This one is just intended to be done on the calculator, so you can, any of the basic kind of things we did in class, you'd be expected to do with a calculator. I do want you to know how to do polar graphs on a calculator. So just to review what you do on this, if you press your mode button, you want to make sure that you're in polar mode. So if you were in function mode, you'd want to move that over to polar, press enter so that you're in polar mode. Okay. Now with this particular problem, typically I might give you an interval. So we're going to graph this from 0 to 2 pi, and then you can kind of use the window of the polar graph that I give you. So you want to go ahead and get your window set up. So we're going to go x minimum is 0. Then we're going to go to 2 pi. And then this increment, this t-step, you want to leave that real small because your graph won't look well. So just keep that like at 0.1. And then we'll go negative 8 to 8, just like this graph is. Okay, and scale of 1, then we'll do the y values, the same thing, negative 8 to 8 by scale of 1. And then we need to go to y equals and then put in our graph. So we're going to go y equals, put in 4 plus 4 sine theta. And it's real helpful on this problem, before we graph this, if you know that this is a cardioid. Okay, and the other thing that's kind of helpful on this problem is, since there's a sine, the dimpling of that cardioid is on the y-axis. So it's going to kind of like Pac-Man eating the y-axis like that. So what we do is we just go through, now we type graph, and this should graph this out for us okay. I've got something wrong. I may be in the wrong mode on my calculator. That's what the issue is. So when you're doing this, you want to be sure you're in radian mode. I've been in degree mode for all the triangle problems. So let's do that, fix that, and then out will come your graph. And it'll do the dimpling around the y-axis as we expect it to. Then all I really want to see is just some key points. Now you can trace on this too. You can, like if you trace at 0 degrees, so you're getting 4. So you can put a dot on 4 to start with. Okay, when you do that. And then you can trace at anywhere you want to. You can trace at pi over 2 if you want to. So we can go pi over 2 just to get this accurate and make sure. So you've got y equals 8. So that means you're going to put a dot here. So we got a dot there. Then we can go to pi. We can trace at pi, which will give me a value of -4 now. Okay, so I can go ahead and do that. Okay, get that dot. Okay, so I've got that. So I've got 3 good dots on this. Then I can trace at 3 pi over 2 if I want to. You can also do a table of values. I'll show you how to do that. So that goes to 0. So now you're back at the point at 0 like that. And then that's good enough. You can go through, you kind of know what it looks like. So then you can go ahead and just sketch the rest of it like this if you want to. You know it's a cardioid. So then you can go through and just draw your sketch like that. All right, and the other thing you can do is you can do a table of values on this. You can go second graph. Now what it's doing is it's incrementing it by very, very small angles. One thing, if you want to learn how to do this, you can do this table set. You can go second window and table set like this, and then this is the increment. So if you wanted to increment this, say, by, let's say, pi over 4, or even pi over 6, if you wanted to increment like that, when you do your table of values, then it's going to have everything by 30-degree increments. So you can increment that pretty much however you want to do that. But you don't have to do that because you've got your graph, you've got your key points, so that's all you got to do. Okay, now moving on from here, I want to review the ambiguous case of the law of sines and go over that and just kind of show you what you need to do on that. All right, so to begin with, the first thing is you want to verify that I've given you the ambiguous case. So let's start that way, basically by drawing a triangle on this first thing. So let's go ahead and get a triangle drawn out on this. Okay, so we have, I'm going to draw out, it looks like angle B is a little bit bigger than 90 degrees, so I'm going to try to draw this, reasonably to scale. Okay, like this, so this would be a possible triangle, so I'm going to label this as B, I'm going to call this A, and I'm going to call that C. So it looks like I've given you that angle B is 98 degrees, I've given you side B is 3, and I've given you side A is 23. So what I've given you is ASS. So I've given you the ambiguous case. I call it ASS. Textbook is more politically correct and call it SSA. So I always say if you see the S in the triangle, then you know it's a ambiguous case. So you know it's either going to have no solution, one solution, or two solutions. Okay, so what you actually do is you just go ahead and start crunching it out. If you're going to use law of sines, you got to start by finding A, because you do know its opposite side. So we're going to go ahead and set up law of sines. So we say sine of A over the length of the side opposite. Then we get the next angle we know, which is 98. So we say sine of 98 degrees over its side opposite, and we do that. Then the calculator will tell you basically if we have a solution or not. So I'm going to multiply both sides by 23. And then I'll go directly to the calculator. So I basically need to just do sine of A is equal to 23 sine of 98 degrees all over 3. All right, so we need to make sure we're in degree mode. You are going to have to kind of be careful about that on the exam because you want to be in degrees for triangles, but you want to be like in radians if you're doing a graph of a polar equation. All right, so then what I do is I just go 23 sine of 98, and then divide by 3. Okay, and that'll give this value. So that'll give sine of A is equal to 7.59, approximately like that. Now what you need to know is if you do the inverse sine of this value, 7.59, you're not going to get a triangle because that's out of the domain. The domain of an inverse sine goes from -1 to 1. Even if you forgot that, if you did the inverse sine of on your calculator of 7.59, you're going to get an error. Okay, so that just means that this particular problem has no solution. All right? So that would be the solution of that ambiguous case. The idea on ambiguous case is it all revolves around this statement. This statement right here is either going to have a solution, or it could have one solution or two solutions for the angle, and then you can use that to reason out how many solutions it has. Okay, so let's do the next one here. And with this one, try to draw this to scale the best we can. I'm going to go ahead and just draw out a angle A, since that's given, as 30 degrees. And we'll just draw a possible triangle. If it's not drawn to scale, it doesn't matter. So I'm going to label everything. This is A, and A is going to be given as 30 degrees. Okay, then I am going to call this B. So the other parts of the triangle we're given A is 23, and we're given B is 46. Okay, so let's see if we see the S in the triangle. So ASS. So beware of the S. And then what you want to do is just set up the law of sines. Okay, so we're going to have to set this up like this by starting with the angle B. So when we do that, we're going to say sine of B over the length of the opposite side is equal to sine of 30 over the length of its opposite side like that, and then we can solve this problem. So I'm going to multiply both sides by 46. Then we'll go to the calculator and see if we can reason out how many solutions I have. All right, so I'm going to do 46 sine 30 over 23. And then this statement will tell us if we have a solution or not. So let's do that. So 46 sine 30 divide by 23 is going to give 1. So that means that we are going to have a solution on this problem. Okay. All right, so what we do is we can go inverse sine of 1, and that really goes to the unit circle anyway. That gives, whoops, I did something wrong there, obviously. So I'm going to go inverse sine of 1, which will give me 90 degrees. So that's one angle. So B is equal to inverse sine of 1. Like we said, B is equal to 90 degrees. So we can go ahead and we can solve this triangle then. All right, so as I go through and complete the triangle, I'm just going to make an answer blank for what I need to find. So we need to find angle B, which we found. We need to find angle C. And then we also, if that's C, we need to find side C like that. Then we're going to go ahead and use the law of sines to do this then, okay? So we now know that angle B is 90 degrees. So if I wanted to find another part of the triangle, of course I could find C just by subtracting 180 minus 30 plus 23. So I'm going to go ahead and do that on the calculator. So 180 minus the 30 and then minus the 23. Hold on, not 23. I'm sorry, it's 30 and 90. Okay, I'm looking at the side. Okay, so that's going to be 60. So we've got a 30-60 right triangle, like that. Okay, then that leaves us to find one more value than we got the triangle solved. So what we're going to do is going to use law of sines. So I'm going to match C over the angle C. Then I'm going to match 23 over 30. You could also work with B and 46 if you want to. So finish up the problem. We're going to say C over sine 60 degrees is equal to 23 over sine 30. And then we can solve using our calculator. So I'm going to multiply both sides by sine 60. And let's go to the calculator to crunch that out then. So we got 23 times the sine of 60 degrees divided by the sine of 30 degrees. Like this. So that's going to be about 39.9 or 39.8. And then that will give a solution to the problem. Okay, so that's the ambiguous case. Typically, I look at the no solution and one solution case. Two solution case is just a lot of work and it's kind of time consuming. So we got time issues when we're taking tests. Okay, so that should wrap that up. And hopefully you have a very good test. Hopefully you make a high score. This test is a little bit simpler, as I've said, than the second test. And hopefully this does well. And then we'll start reviewing, finishing up, and reviewing for a final exam.